Okay, a couple short ones here. Is this true or false? Graph of every cubic polynomial has precisely one inflection point. Well, let's see. P of x is ax to the third plus bx squared plus cx plus d. If we're looking for inflection points, we have to find our derivatives in order here. P double prime would have to be 6ax plus 2b. Okay, now, assuming that a was not a 0, we would have one solution to this equation. So that means we would have a possibility of an inflection point. Then you'd have to test to see if it changed sign. Now, since this is a linear equation, as long as a is not 0, its slope's not 0, and it would cross, it would do something like this or like this. It would not be a horizontal line because it has a positive slope. Oh, it has a slope, but not 0. So it would have one. Wherever this line crosses the x-axis, that would give us our inflection point. So yes, it is true. Okay, next one. This graph is concave downward for negative x and concave upward, and therefore it has an inflection point at x equals 0. Well, inflection points do occur when the concavity changes. However, this one, if you remember what it looks like, does that and that. It does not have a point at x equals 0. So even though the concavity is up and down, down, up, okay, it's not an inflection point. It's an asymptote. Okay, so that's false. If f prime of c is greater than 0, then f is concave upward at x equals c. Well, only if, well, first of all, f prime of c, we don't know anything about the concavity if we're looking at the first derivative. So you couldn't say that that's definitively true. So we have to go with a false. Even if you find one instance where it's false, then it's false. Okay, next one. If f double prime is 0, if 2 is 0, then the graph must have an inflection point at x equals 2. Not true. We know it has a potential inflection point at x equals 2, but it would have to be tested to see if there was a sign change. So that is also false. Okay, so some conceptual questions there to wrap it up.